we are looking at inverse trig functions today. So not regular trig functions. We already know the derivative of sine and cosine and tangent and cosec. We know those are derivatives of the trig functions. So today we're going to talk about the derivatives of inverse trig functions. They exist as well. So just to make your life more fun. All right, so what Dr. Taylor does on the video, so if you haven't watched it, I know most of you have done the quiz, so you should be okay. But remember, an inverse trig function is switching x and y and resolving for y. So when an inverse trig function, you're not looking for the cosine or sine, you're looking for the angle. Okay, so it's backwards. They're going to give you the trig function. They're going to give you like the sine is 1/2. What's the angle? So that's doing it the opposite way. Okay, so also at the bottom, I don't like the table, but table's there in case that helps you, what values are what. I like just looking at this to kind of do sine, cosine, and tangent. Okay, so make sure you're okay with those. You might be asked that. So the whole first page of notes, page 105, we're all done with Dr. Taylor, so that's doing the trig function. Okay, now none of these have the arc, so let me do that. So we'll start on page 106. Okay. All right. So the first thing, I think, the easiest way for you guys to learn this is just to memorize these. I'm going to show you how we arrive at the sine function, the inverse sine derivative, in just a minute. So I want you to know it just didn't come out of the sky. But I'm not going to do all of them with you. So those pages A34 and A35 in your appendix, some of the instructors use all of those and want to go through all of those. I just, once you see it once, you kind of get the idea. So I'm going to do one with you. All right, but before we do that, I just want you to remember that when you write an inverse trig function, so for example, this is the inverse of the sine function, right? The other way to write that, old school, is the word arc. So instead of using sine to the -1, sometimes you'll see the word arc in front of the trig function, arc sine. Those are exactly the same, okay? So arc sine, you'll see in problems. You're more than welcome to switch it to inverse sine this way, but they are one and the same. And I mention that because some of the problems in WebWorks have the word arc in front of it. Some of the problems in WebWorks will have the shortcut way. So this is really the shortcut way to write this. Okay, this is the real way. It's the real way you write that. It's just, this is shortcut notation. All right, so let's talk about the arc sine, and let's look at our derivatives, and then I'll kind of go through that with you. So again, notice cosine, cosecant, cotangent, all have negative derivatives. So that rule is a nice rule to remember. Always the ones that start with C have the negative signs. And then they kind of match up. So arc sine and arc cosine have the same derivative, except cosine's negative. Tangent and cotangent have the same. So all you got to do is remember 3. And then you've got your cosecant and secant. They go together. So really only 3 new derivatives. And then just remember the ones with the C's are the negatives. Okay? All right, so let's take a look. I'm just going to do this over here since Dr. Taylor did those with you. I want to look at how we got that the derivative of the inverse sine was 1/√1 minus x squared. Okay? So let's talk about our original function. Y equals the sine of x. So I just want to do this with you quickly. Y equals the sine of x. So if we were going to do the inverse, if I asked you to find the inverse of that, you would switch your x and your y's around, right? So you would get x equals the sine of y. All right, so this is how we do the inverse. So y equals sine of x is the function. X equals sine of y is the inverse. So if I were going to graph that, I want you to see this graphically, which you may not have done in a while, but all right, so if I draw an angle in the first quadrant, then remember, the sine of the angle. So y is your angle, x is the sine of that angle, right? That's how you read that. Usually it's the sine of theta, but in this case we have y. So this angle right here is y. Okay, the angle is y. And the sine, which is opposite over hypotenuse, right? Sine is opposite side over the hypotenuse, is x. So that means the opposite side is x, and the hypotenuse is 1. Right? Going back to kind of how we always did all our trig stuff. Okay, so again, look at that. So here's angle y. The opposite side is x, and the hypotenuse is 1. So if I asked you what's the sine of this angle, you would do opposite over hypotenuse, right? X over 1. Does that make sense? If you remember all that. Okay, so there's our triangle. So how do I solve for this side? So I'm going to call this side A. I want to solve for A. I'm not going to put an A there because I don't have a pencil and I don't want to scratch it out. So let's do the Pythagorean theorem, which would be a squared plus x squared equals 1 squared. Right? That's how I would solve for the missing side of a right triangle. So a squared plus x squared equals 1 squared. So a squared is what I'm solving for, is 1 squared minus x squared. And 1 squared is just 1. So a squared equals 1 minus x squared. So what does a equal? Square root of that, right? All right, so this side, side A, is the square root of 1 minus x squared. Okay? All right, now, let's go back up here to x equals the sine of y and find the derivative. Because that's what we're doing. We're finding the derivative of the inverse, right? All right, so this is implicit. We're going to do the derivative of x equals sine of y implicitly. So what's the derivative of x? 1. Derivative of the sine of y would be the cosine of y, dy dx. That's not an x term. Okay? So that means dy dx, if I solve for dy dx, would be 1 over the cosine of y. Right? Divide both sides by the cosine of y. I just wrote it backwards. So dy dx is 1 over the cosine of y. All right, so 1 over. Now go back to the triangle. What is the cosine of y? Cosine of y is adjacent over hypotenuse. So what is the cosine of y? That would be the square root of 1 minus x squared over 1. And look at what your derivative of the inverse sine function is at the top of your paper. That's exactly what we got, right? So it's kind of weird how you find it. So you don't have to find it, you just have to know it. So that's the good piece. But that's kind of how it's done. So you could do this for every single trig function. You could do cosine, set it up the same way. You could do tangent, which is opposite over adjacent. I just chose sine because it was the first one up there. Okay, but I want you to see kind of what you're doing. So you're finding the derivative of the inverse function, and that's kind of the way that it goes about it. All right, so learn those. Got to know those. It's only 3, so it's not too bad. Okay? All right, so now we're going to do just a few more problems. Really don't have a whole lot today, but we're going to do the derivatives of these, but they're all going to be combined now. So we have regular trig functions. We have all the logs and exponential rules, and now we have the rules for these, okay? So the biggest thing I can tell you about these rules is when you take the derivative, this x right here in the formula is for whatever is in the parentheses, that argument for that inverse trig function. So since that's an x, that's why that's an x. But if I had the inverse sine of 3x squared, then that x would be 3x squared, and then I have to square that. Okay, so whatever the argument is, that's what goes in place of the x. It's not just x. So that x, those go together. So as we do these, I'll keep mentioning that, because that seems to be the piece for some of you that you kind of get hung up on. All right, so we're going to start with number 12. Dr. Taylor did a few of these. So we're going to use chain rule, product rule, quotient rule, whatever we need, and solve these problems. All right, so number 12 says find the derivative of the arctangent of x raised to the 7th power. So this is a chain rule. Okay. Also today I'm going to clean them up a little bit for you because a lot of these on my test are multiple choice. So you kind of have to be able to find the answers if they're cleaned up a little bit. Okay. And it's usually the same way on the final bit. Okay, so what's the outer function? We're doing a chain rule. We doing the inverse tangent first, or are we taking something to the 7th power first? 7th power first. So I just need the derivative of anything to the 7th power. So that's 7 anythings to the 6th power, right? We're just doing our power rule. All right, so that's how we're going to start. So the derivative of the outer function, something to the 7th, is 7 of those somethings, leave them alone, to the 6th power, right? Subtract 1 from your exponent. So that's the derivative of the outside. Now we need the derivative of the inside. So we're going to do now the derivative of arctan. Okay? So I'm going back up here. Since there's just an x in the parentheses, I'm just going to use this formula right here. So the derivative of the inverse tangent or arctangent is 1 over 1 plus x squared. So times 1 over 1 plus, and the only reason I'm putting just x squared there is because that's an x right there. Okay? Now, that one can't be cleaned up a whole lot other than you can write it as a fraction. So if I wanted to clean this up, I could just write it this way. Okay? Probably all I can do on that. And please remember the word arc. You can use arc, you can use that -1. It doesn't really matter. Okay? All right, now number 13 is good because now I'm doing the inverse cosine, and then there's your x. So your x in this problem is e to the 8x. So when you substitute it in, that's what you have to sub in. So this is still a chain rule. We have the outer function, inverse cosine, we're going to do that first, and then we've got to do the derivative of the inside. Okay, so I keep sliding back up here for now, but you guys can look at this. So the inverse cosine is what we just did in our little picture, except it's going to be negative. So it's -1 over the square root of 1 minus whatever's in the parentheses squared. Okay? All right, so we're going to start with that. So the derivative, -1 over square root 1 minus e to the 8x squared. Okay, so whatever's in that parentheses, that's your x. So it's that thing squared. Now we have to do times the derivative of the inside. All right, so what's the derivative of e to the anything? E to the anything times derivative of the exponent. Derivative of 8x is 8. Okay, now all of that is in the numerator, so if you wanted to clean this up, we'd get -8 e to the 8x in the top over square root 1 minus, I like to practice this with you. What is e to the 8x squared?
16.
Because I guarantee you the wrong answers are going to be one of your choices on multiple choice.
64 squared.
16.
No, not 64. What do you do when you raise a power to a power?
Multiply.
You multiply. Okay? What do you do when you have this? What is that? X to the 5th squared. That is x to the 10th. You multiply. So what is 8x times 2? 16x. Not 16x squared, not 64x squared, but that is 16x. And all of those wrong answers you just told me, those are going to be multiple choices. So you have to know how to do that. So even though you like multiple choice, I tend to not like multiple choice because you guys, if I just said leave it, you wouldn't make that mistake. Don't clean it up. But if you have to clean it up, sometimes mistakes are made. All right, so there's your answer if I were to do that multiple choice. And obviously there'd be a positive one of those as well, right? So I don't like multiple choice in math. They're too close together. You got to be very careful. So take your time with those. All right, we okay with that one? All right, so last page, let's look at these. So just getting crazy now on the back. All kinds of fun problems. That's why that worksheet A36 is really good for you guys to practice. Because I don't do that many of these with you. I mean, there's not a whole lot new stuff, just these formulas. So you just got to practice with them. Okay. 14 is written as arc sine. So if that messes with you, change it to sine -1. It doesn't really matter. You want to do that? You guys like writing it that way instead? So let me do that with you. So I'm going to rewrite this as f of x equals inverse sine of that. Same exact thing, okay? So that's why I said, in web work, you'll get problems that have that arc in front of it. So just change it if you feel better, more comfortable using that notation. All right, so this is another, well, it's actually a triple chain rule. So the outermost function is inverse sine. Then the inside function, the middle function is the square root function. And then the inside function is 4x minus 1. So we have to do 3 different derivatives, okay? Okay, so, and then we're going to try to clean it up. That's the fun part. All right, so we're going to start with the derivative of inverse sine. That's the outermost function. So the derivative of inverse sine is 1 over the square root of 1 minus whatever's in here squared. So square root of 4x minus 1 squared. Okay, so that's the derivative of inverse sine. Okay, so we got that. Now we got to do the derivative of the inside. So this is, remember, 4x minus 1 to the 1/2, right? That's the square root. So now we're going to take the derivative of the square root of 4x minus 1. So bring the 1/2 out front, and then 4x minus 1 to the negative 1/2. Subtract 1 from your exponent. So that's the derivative of the square root function. Now, times the derivative of 4x minus 1. So that is 4. Okay? So if I had this on the free response, you'd be done, move on. If it's multiple choice, that's not what you're going to see. So let's talk about cleaning this up. All right, so let's start with the first fraction. Let's just clean this up first. Okay? So we have 1 over, and this is where some of you will mess up, so that's why I like to do this with you. 1 minus, all right, what happens when you square a square root? They cancel each other out. So you end up with 4x minus 1, but it's in that parentheses, right? Don't lose your parentheses for a minute. All right, times. Now let's look at the other side. So we have 1/2 times 4. So that's going to change to 2, which will be in the numerator. And then this is in the denominator. So this is 2 over the square root of 4x minus 1. Okay, so how does this simplify? Do the ones cancel out? They do not, right? I hope so. You got minus, minus. So that's plus 1. So you got 1 plus 1. So now I've got 1 over the square root of 2 minus 4x. So that's probably a mistake some of you would make. Times 2 over that. And since I have different radicals, we usually wouldn't multiply that. So we would just write that as those two together. You could, but I would guarantee that it's probably going to be written this way. All right. See, so cleaning up isn't always fun, but we are going to have to clean up after we finish this test. We're going to be cleaning up all the time, so we got to practice that. So again, if this was a free response, and I may have some free response, if I have free response, you would have been done right there. And that's what I want to see because you're just practicing. I try not to do a whole lot of crazy ones on the multiple choice because I don't, I'm not trying to trick you. But you do know how to, it's just simplifying, so you should know how to do things. Okay? Yep.
In the second step, did you leave off the 4 times 4?
In the second step, what?
Did you leave off the times 4?
No. You got to do the derivative of the inside, right? That's a chain rule. So you did the derivative of the outside, but then you have to do the derivative of the inside.
I mean the next step, the simplifying.
Or you asked me why I left it off?
Oh, you multiplied 4 multiplied by half, which gives you 2.
Right.
Yeah.
Which is that?
Oh, okay.
Is that what you?
Yep.
Okay. All right. Yep, the 1/2 times 4. I simplified that to the 2. Thank you. See, our brains all work together. Okay. All right, so there's that answer. So that was fun. So the derivative wasn't too bad, but the cleaning up process is. So you just have to be careful with that. All right, how are we going to do number 15? What kind of problem is that? Where am I starting on that kind of problem? Product rule, right? 1 plus 16x squared times the inverse tangent of 4x. So this is a product rule. So we'll do the product rule, and then we'll try to clean that up a little bit. All right, so not too bad of a product rule, if you see that it's a product rule. All right, so we're going to start with the derivative of the first function, which is 1 plus 16x squared. So what's the derivative of that? That's the easy piece. That's 32x, right? So there's the derivative of the first times the second. Leave it alone. Okay, plus the first function, so leave it alone, 1 plus 16x squared, times the derivative of the second. Okay? So inverse, so this is a chain rule. So we're going to do the derivative of the arctangent, and then times the derivative of the inside. So remember, arctangent is the one without the square root, and it's a plus. Okay, so that's kind of how I taught myself these. I always remember the tangent is no square root, so that's the positive one. And then sine and cosine are the minus ones, and those are the ones that have the square root. And then for secant and cosecant, just remember it's reversed underneath the radical. The x squared comes first, and you have just the extra x in the bottom. Okay, so they're kind of a lot related to one another, so they're easy to get mixed up. All right, so 1 over 1 plus, what am I putting in squared? It's not just x squared. It'll be 4x squared, right? So whatever's over here is what you're squaring. Okay, so that's your x, 4x. So 1 over 1 plus 4x squared times derivative of the inside times 4. That's in the numerator, 4 over 1. All right, so that would be your answer if it was free response. Okay, but let's clean it up. So the left piece, I can't really do much with 32x inverse tangent, so I can just get rid of parentheses. Okay, so there's that left side. All right, so let's look at the right side then. So in the numerator, I have 4 times this, right? So I'm not going to distribute. So just 4 times this goes in the numerator. And in the bottom, let's go ahead and square 4x. So we have 1 plus, now 4x squared means 4x times 4x. So 4x times 4x, 16x squared. Okay. Good. So what am I going to do with those 1 plus 16x squared? They're canceling. Look at that. So my answer is 32x tangent, inverse tangent of 4x plus 4. So there's your derivative. So again, not cleaned up. First step, if it's free response, you would leave it just like that. If it's multiple choice, you may have to work it out a little bit more. So now you're probably hoping I don't have multiple choice. I don't know. We'll see. I know you can still guess on them, but. All right, 16. I'd like for you to look at that for a minute. This one has a natural log in front of it. So do I want to do a natural log and a quotient rule? Or do I want to expand because I got a natural log? I would like to expand this thing because that's going to make it a whole lot easier. Okay, so that natural log right there gives me the option of making this a 2-problem step where you have a subtraction problem, instead of having to do a nasty quotient rule. Okay, so I'm going to expand first. So I'm not going to do derivative yet. So I want to expand. So f of x equals the natural log, and I'm going to change arctan to tan negative 1, okay? Just because that seems to be what we... Arctan of 3x minus the natural log of 5x cubed. Okay, so now I got 2 separate problems to do that aren't quite as difficult as that original problem. And I can only expand it because of the natural log. Okay, so now we're going to do derivatives. So remember, the derivative of any natural log is 1 over that whatever you take the natural log of, and then times the derivative of the inside. Right, that goes in the numerator. All right, so we're going to start with natural log of inverse tangent of 3x. This is the fun piece right here. All right, so the derivative of natural log, that's the outer function, is 1 over whatever you're taking the natural log of. So that's the derivative of the natural log. Okay, 1 over whatever. Okay, now times the derivative of the inside. So now we need the derivative of arctangent, which we just did above. The derivative of tangent is 1 over 1 plus x, which is 3x in our case. So 1 over 1 plus 3x squared times the derivative of the inside, which is 3. So all of that is that first derivative. I'm going to just bracket it so in case you go back. So that is the derivative of the natural log of the inverse tangent of 3x. Okay? I'll say it one more time. Start from the outside. So any natural log is just 1 over whatever you're taking the natural log of. Then the derivative of the inside, so arctangent. And then the derivative of the inside. All right, minus. This one's a little easier. This derivative of the natural log is 1 over whatever you're taking the natural log of. And then remember in the numerator, we did it different, I put it up here instead of the 1. But you could just do times the derivative of the inside, which is the 15x squared. Because I'm going to clean it up in a minute anyway. So you could just write that 15x squared over 5x cubed. That's how we did it on Wednesday, last Wednesday. Okay. So not a whole lot of cleaning up. This one, I'm just going to leave it kind of the way it is. You can make this 3x squared will be 9x squared. And then you can put the 3 in the top. So we could write that as 3 over arctan of 3x times 1 plus 9x squared. Do that. Minus. And then I definitely can reduce this. 3 over x, right? So minus 3 over x. 15 divided by 5 is 3. That stays in the numerator. And then you'll have 1x left in the bottom. So that's simplified.
So we won't have to get like denominators if we have something like that.
No. And you can leave, if you have radical in the bottom, that's okay too. We don't. Yeah, I wouldn't ask you to get a common denominator on that. Good?
Actually, multiply by 3, you just multiply the numerator.
Good? Okay. All right, so the last one, what do I got to do with that? I got an x in the base, and I got an x in the exponent. So that's the only way I can solve this, or find the derivatives. That's what we learned last week. That's that logarithmic differentiation. I have to, anytime you see the variable x as a base and the variable x in the exponent, you must, no choice, you got to do logarithmic differentiation. So that's where you have to take the natural log of both sides. So instead of f of x, remember we're going to write that as y equals, because I'm going to do implicit. So f of x is the same thing as y. All right, so we're going to do logarithmic differentiation, which is to take the natural log of both sides. And again, I'm going to write arc cosine as inverse cosine this way. Okay, so take the natural log of both sides. All right, so that was the first step. And now we're supposed to expand this side, so we're going to bring the 2x out front. That was the second step. 2x times the natural log of this. Okay, so that was step 2. Step 3 is to do implicit differentiation. So natural log of y is 1 over y dy dx. And on the right side, it's always a product rule. At least 2x is good. We only have one of the harder pieces. All right, so we're going to do a product rule. 2x is your first function, times, and then this natural log inverse cosine is your second function. Okay, so we'll start easy. Derivative of the first, so the derivative of 2x is 2. Leave the second alone. Okay, so that was the fun side. All right, and now we'll do derivative, or the first, 2x. Okay, so now we're going to do the derivative of the natural log of the inverse cosine of x over 4, which is similar to kind of what we did here, right? So kind of like 16. All right, so we're going to start with the derivative of natural log, which is the easy piece. Derivative of natural log of anything is just 1 over anything. So that would be 1 over the arc cosine x over 4. So that's the derivative of natural log times the derivative of arc cosine. Okay, so the derivative of arc cosine is negative 1 over square root 1 minus this squared. So x over 4 squared. Not done yet. Times the derivative of the inside. What's the derivative of x over 4? Remember, that's 1/4 x. So what's the derivative of 1/4 x? 1/4. All right, so don't make that a quotient rule. Do not do a quotient rule. That is 1/4 x. It's just a constant, right? Or the linear term. Okay, so see, if you didn't have to clean it up, we'd almost be done, but we're going to clean it up. So now we have to solve for dy dx, and then remember to replace the y with the original function. All those rules apply. So let's clean this side up a little bit before we do that. So I'm going to leave the 1 over y there for a minute. All right, so not much with the first one. Just get rid of the parentheses. Oh, that's really going to be minus, isn't it? I got that negative 1, so that's going to become a minus term right there. All right. X over 4 squared, you could leave it. You could write it as x squared over 16, right? That would be that. And then we have the 2x. We got a negative 1, and then the 1/4 over here. So that's 2x times 1/4 would be x over 2. And then you got that negative, right? So, so minus. So the only thing in the top, I believe, is x. 2 is going to be in the bottom. Arc cosine. And then the square root 1 minus x squared over 16. I wouldn't care if you left it x over 4 squared. Again, this is just if it was multiple choice, because especially on the final. I don't make the final, so I don't know. I need an extra sheet of paper. Okay. Ew. Does that look good? 2. That, the x was on the top. Everybody okay with that? All right. I don't think there's a whole lot more I could do. I mean, I don't want to factor out that because that's in the denominator. So dy dx equals. So we're going to do y times this, and in place of y, you're going to replace it with the original function, right? So I'll write it twice. You don't have to. So y times this. You guys want to sub in y right away? You can. I would do that if I were you. If you like all the steps, then write all the steps. All right. Okay, so that's what we got. And then we're going to replace the y with the original function. So our original function was this times all that. I feel like by the time you get through this, you've left one little thing out, which is very easy to do. So just take your time. That's why I can't talk and write at the same time. All right. I believe what we got. Okay. I'm pretty sure on my test, I do not have this as a multiple choice because that way you can kind of do what you want. Like, you could leave that x over 4 squared. I wouldn't care if you left that. So as long as I see that you're kind of on the right track. All right, Sean, we can stop on that one.